that that guy, Mohammed Rilwan, the only guy which is participating. What we call is not participating. He's the only
What is
person
the
who is
last answer
answering.
to?
Again, what is your question?
No, what I'm saying, I don't know how much persons are here and who is
11th answer.
Wait just please, Engineer Muhammad. Again, yes.
okay, fine. No issues.
You can tell us again.
Okay, it's fine. I can hear only that person's sound, Mohammed Rilwan. Yeah.
Actually, if everybody talks, then nobody will understand anything. So
Yeah.
that's why it's better to type, I think.
He raised your hand now.
Okay, fine. Okay, fine.
Welcome. 13.
D.
Specific volume C, I think.
Heat. Heat, it is not a property.
Okay.
Heat is a path function.
Okay.
14.
D8.
14. Anyone solve it?
No, I didn't solve.
Okay, let's see the answer together. 15.
So the following items.
I put VDP.
Which
VDP.
one?
I'm talking about 15.
15 or 14?
14, we don't solve.
Yeah, 15.
D.
No. 15 is thermal
Eight.
conductivity. Because thermal conductivity is a property, not path function.
Okay.
Okay.
16.
54% degree. 54. Yeah.
A.
A.
Yeah.
Let's see answers together.
Okay.
17.
760 degree. Yeah.
All agree?
A.
Yeah.
Okay, A. 18.
Oh, propose on like already.
D. All the above.
All above. 19.
A.
A.
A. 20.
False.
False. 21.
21, I put D.
D.
21 is
B.
B. 22.
B?
B, yes.
21 is B?
Center of points, yes.
Okay.
22.
Put this viscous. D.
D.
D, viscous force.
Yes.
23.
3 is uniform.
C.
No, it's vortex.
Free vortex.
C.
C.
Free vortex. C.
Free vortex, yes. C.
Oh.
24.
Laminar.
Any other idea or all agree for laminar?
Turbulent.
Turbulent.
Yeah, but the answer is comes 200.
200 or 2000?
2000. Yeah, 2000.
It's
Or
less
20,
than 60,
or 2000.
60,400.
2000. Yeah.
Not 20,000?
Yeah. 2000. 200 plus 10 power 1. Total 2000.
Okay, let's see.
Okay.
25.
What's the answer?
Mute mic, please. Anyone not solve or sharing with us, mute mic.
Is that laminar?
25. The 24, we will solve it together.
Okay.
Because we have a debate here between laminar and turbulent. 25.
B.
25A. Yes. Let's go to check the numerical problems.
Okay.
It's 25. So Question number 25.
25? 25 is A.
Yes, question number 25. Answer is
A.
it's asking that as for local code, I want to ask this question that we at least quarterly we check or semi-annually we check the power transfer. How this become annually?
When annually and when semi-annual and something like this?
Yeah.
Yeah, we have session for this one. No problem.
Okay.
We will
So we will cover in that one.
Yes, we will.
Because not giving us QCDD or NFPA. NFPA says
QCD ask more detailed for many questions. For NFPA, it's just specific for some questions, mainly related for the inspection time, testing time.
But we check every 3 months minimum.
Related for alarm and the fire and safety, related for anywhere.
No, he's asking the power transfer, no, the Kaharama or generator power.
Kaharama and generator power? I don't see this question before.
The question is, he's asking that change of power transfer meaning generator power or Kaharama power.
No, again question.
Yes. Can you just open that question?
Your voice,
voice not clear. The voice.
Engineer, your voice is breaking. Actually, you cannot understand your question too well.
1 second.
There is issue in your head speaker.
Can we just write this question on the chat? Just I need to. Okay. But write it after I finish the exam. Okay, I will keep 2 minutes for refresh after finish the exam. You can write the question. Okay. Now focus with me for the answers, please. 2 streams discharge into a pipe. As shown in the figure, the flow are incompressible. So we can follow the continuity equation direct. We will study today continuity equation. This is the first thing we will start. So, and we will see this one. This is what it is. At the beginning, we see circle. And now this happy face. But now it's continuity. Okay. This is one of the famous equation used in the exam. Okay. Q equal AV. Q is the discharge. A is area, V is velocity. So here, the volume flow rate at stream A into the pipe, this is stream A. QA is given direct 0.02 T meter cube per second. And that of stream P by QB is equal to 0.008 T square meter cube per second. So where it is in second, the exit area of the pipe is 0.01 meter square. Find the velocity of the flow at the exit at time t equal 1 second. So at time t equal 1 second, the required is velocity. As per continuity equation we will study today, and we know from where this is coming, sum of the Qn is equal sum of the Q out. So how many n? A and P. So QA plus QB, this is the n. How many out? One output, which is, for example, Q3. So this equal Q3 or equal Q, because we don't have, or QC, whatever. Okay. So QA, it is given direct 0.02 T plus QB is given direct 0.008 T also square equal to Q, which is equivalent to AV, because it's not given direct. So I will go for the meaning of QAV. So I put it here AV. He needs to calculate velocity at time t equal 1 second. So substitute for time t equal 1 second. So this one, it will be 0.02 as it is. This would be 0.008 as it is. Equal area, which is 0.01. All these units is meter cube, meter cube, meter cube, meter square. So unit all accepted unit.
Excuse me, is it 0.01 or 0.028?
Which one? This one?
There's some.
Sum
0.028, right?
here.
0.028.
Yeah, I don't put the sum till now. This is the area. I substitute the area here.
Okay.
So this, it will be 0.028 equal 0.01 velocity. This is 0.01 area. So the velocity is equal 0.028 divided by 0.01, which is equal to 0.8 meter per second. Any question for this one?
Clear.
Okay, let's continue. Okay. Again, as per the continuity equation we studied today, sum of Qn equals sum of Q out. So QA plus QB, this input here, this input, equal to the output, which is this Q. Okay, this one is 0.02 plus 0.008 t square, and this is t equal to Q. He needs all this at t is equal 1, so this 1, this 1, so is the sum of this is 0.028 equal Q. Now I know the Q here. This Q is equal AV. A I have, so the required actually is V. This is the exact required. So this Q is equal AV, which is equal 0.028. So V is equal 0.028 divided by the area, which area which is equal 0.01 as per given here. So this equal to 0.8. Another way for solving. Now it's clear?
Yes.
It's clear.
Okay. Question 7. He gave eta for turbine, eta for generator. The efficiency for eta for all is equal eta for turbine multiply eta for generator. We will see this in detail the next session, inshallah, for next Saturday for session of pumps. Why we're going to multiply these two together. 0.8 multiply 0.9, which is equal 0.72. It means 72%. Okay. Question number 14.
Sorry, Doctor, one step back.
Again?
Yeah, for the efficiency.
For the
Efficiency. Question 6, sorry, 7. Yes, the one which we just, this one. This is for turbine and generator, right?
this.
So we have to multiply.
Going to multiply, yes.
Okay, so answer number 7 is the answer is C.
Yes.
Okay. Not sum, right?
This multiply.
It's multiplication.
Okay.
Because I saw some answers for the same question, which is some traditional websites have added this one.
No.
So the correct answer should be multiply, right?
Multiply. $14. Below figure, assume gamma water is this blah 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 9810 Newton per meter cube. S mercury is 13.55. The gauge pressure at point A, he needs the pressure here. So we have one rule for the pressure. What is this rule? For same fluid,
How much?
same height, it will be go same pressure. Same fluid, same height, it will have same pressure. So when you're going to calculate pressure at A, it will calculate it from starting knowing point. Where is the known point? This point. What is the pressure here? The pressure here is normally atmospheric, which is equal to 100 kilopascal absolute or 0 gauge. Normally we use it or consider as 0 gauge. This is regular. So if we go by this way, how to get pressure at A from this point? We will go step by step. Another rule, when we're going down, pressure increase. When we're going up, pressure increase. Sorry, decrease. Okay, so this increase, this decrease. So here, this mercury, all this is mercury. Okay, then going to the water here, that's okay. And going at the end for the oil, and he give you the specific gravity of the oil. It's fine. So the mercury here, all this like this, the same, but for same height like this, same fluid, it means at this point, the pressure, if you get it here, is the same pressure here, correct? So if I consider this one is P1 and consider this is P2, so it will be this also is P2. Then go next. This all is water. I don't change the fluid. So up to this point, all is water. So I will get the pressure here, P3. Okay. Now we change the oil. From water, change it to oil. This is another fluid. So we calculate again another pressure. So this oil, just take leveling like this. Same height. So same height, same fluid, it's same pressure. So the pressure here also again is B3. So from this point to this point, this the same liquid here, gamma, we can get BA. So the sequence to get BA, we need to get B3, because if I know B3, I will go down. So I will just add plus this head, correct? Because this head pressure is the head above the point. If you need the point here, what's the calculation at this point? It is the head above this point. That's it. So if I need the calculation for the pressure of PA, it's the pressure at B3 plus the head above. That's it. So, but I don't know B3. Go back step. B3. B3 here, I get it from B2. B3, it is equal to B2 and
minus
because I go up. I need to get B3 from B2. So I go up. Okay, but I don't know B2. So going back step. B2, how can I get B2? From B1 and go down. From B1, I can add this column to get B2. But you know B1? Yes, it is 0 gauge. So from B1, if I know B1, I can get B2. From B2, I can get B3. From B3, I can get BA. This we can write it as steps: BA from B3, B3 from B2, B2 from B1, B1. That's it. Finished. BA from B3, B3 from B2, B2 from B1. So 3 equations, sequence 3 equations, we can get the answer. And another one, we can get BA direct from B1 in the one equation, just like combine all these 3 equations in one equation. I will just write it at the beginning in details, and I write it at the end again for one step. Okay. For steps, BA is equal, we can write it from regular B2. B2 equal BA1. Going up or going down? B1 and going down, so plus or minus plus gamma H. What is this gamma and what is this H? This is the head. This is the head of column, which is P is equal gamma H. Gamma for the liquid itself, gamma mercury. So this one is gamma mercury. H, which H? This one here, from this point to this point, which is equal what? 1 meter. So this H is
1 meter.
1 meter. So we can write it substitution. Right here is a substitution. 0 plus gamma manometer. Sorry, mercury. How to get gamma mercury? Gamma mercury here is given by specific gravity. So if I have a specific gravity, we can get gamma mercury from this one. How can? S is equal gamma for the fluid divided by gamma for the water. So gamma for any fluid is equal to S multiply gamma water. Correct? That's okay. So if you need gamma mercury from here, is equal gamma water multiply this S mercury. So it is equal what? 139810, which is given here, multiply 13.55. This what? Gamma mercury. So I write it here. 8910 multiply 13.55 multiply 1 meter multiply 1. This H, 1 meter. Now we know B2. B3 is equal P2. B3 equal P2. I'm going up. So minus gamma. Gamma, which gamma here? This is gamma water.
1 gamma
H. Which H? From this point to this point,
1.5.
which is equal 1.5. 1.5 meter. So we substitute B2 from above. This B2. This one should be get it and put it here, which is equivalent to this calculation. Minus 9810 multiply 1.5. So now we get B3. Let's see, PA is equal B3 plus, because we're going down, gamma for, what is this type? Oil. So gamma oil H. And what is H?
1.3.
1.3. So this one, gamma oil. What is the gamma oil? Same like mercury. Gamma oil equal S for oil, which is 0.9, multiply gamma water, which is 9810. Same like we did it here before. So we write here B3 in this way, which is equivalent to this calculation. And plus gamma oil 9810 multiply 0.9. All this multiply 1.3. That's it. Now we get BA. But if you want to get it by one step, we can write it as it is. BA equal to, I start by this one, B1, which is equal 0. I'm going now down, which is plus. This part, which is gamma mercury times H1 meter. So gamma mercury 9810 multiply 13.55 multiply 1 meter height. Then I am here going up, so minus, open bracket. Gamma water H, gamma water is 9810, H is 1.5. I am here, step jump, here, down, plus, open bracket. I'm going down for gamma oil, which is 9810, multiply 0.9, multiply the height 1.3 in one step. If you check this one here, I put it here. So here, there. This one, which is this one minus this one, here. This one minus this one. then plus this one, plus this one. Clear or no?
Okay.
Clear.
Give me a minute. I will note it down this.
It's not take time. I will check the final answer. Answer is 129,688.
0.2.
Yes, 129,688. Yes, exactly. So the correct answer is
Letter B.
exactly yes. Is this question is clear or have something not clear?
Clear.
Clear. It's clear.
Okay. Let's see the question number 16. I see many confused for this question. Perfect gas at 27 Celsius is heated at constant pressure, so P is constant. This T1 till its volume is double, so BV2 equal to V1. The final temperature is, this is the final temperature. At B equal constant, we can follow the ideal gas equations. I think Charles' law. So V1 by V2 equal T1 by T2. So V1 is the same V1. V2 is 2V1 equal T1, 27 divided by T2. Cancel V1 with V1. So what's remaining? T2 equal what?
54.
54, which is wrong. Why? Because
Absolute.
It must be absolute.
must be Kelvin. All temperature must be Kelvin for perfect gas equations. So this one should be plus 273 to be Kelvin. Now T3 is equal what? 600. So the answer is?
Letter B.
She is wrong also. Why? This 600 Kelvin, but the all choices here by Celsius. So we need again back to Celsius, minus 273 to get the answer by Celsius, which is 327. You see how many drops in this problem? Very easy problem to solve, but 3 tricks. If you pass from first one, I don't keep you to run. You see the second drop and then the third one. Okay, so the final answer is 327, which is equal to
Formula is only in Kelvin, unit Kelvin. Huh?
yes.
Formula. What's this formula? Perfect gas formula.
Yes, yes, all ideal gas. Any ideal gas equations use temperature by Kelvin.
Okay. Then volume unit.
Volume, normal volume, no problem. Let's continue. Aha, 24 still remaining. 24. Air is flowing through 6 millimeter diameter. So this diameter, velocity, new kinematic viscosity. So this reduced number, just need to substitute. Reduced number is V multiply D. So we need to multiply 10 to the power negative 3. Don't forget this one to be meter. And the last is new 1.5 multiply 10 to the power negative 5. Be careful for negative 5 or negative 3 and so on. Okay, many confusion for the calculation for this part. First, don't forget this one to change unit from millimeter to meter. There's many traps for this stage. So at the end, you will see this -5, this -3. We can cancel 3 with 5, and the remaining is 2 here. And we can make it up for this 2 above to be easy for you. Okay, like this, you can write it like this: 50 multiply 6, 1.5, and they keep this cancel this one with this one, and the remaining 2. Then go up for the remaining, which is 10 to the power 2. So I think it's easier for calculation now. Okay, so the answer is 20,000, not 2,000. 20,000. Who is getting 2,000? You are not only engineer gets this one. I see this for many batches. Get it 2,000 and the other get it 20,000, but it's very tricky answer. Why? Because actually it's 2,000 is going to select laminar, but 20,000 is going to select turbulent. I agree with you if the answer, by the way, is 40,000, for example, and you get it 4,000. So in both cases, it's turbulent, but he gave you some numbers to be clear. If you get this, you select another choice. You understand me? So be careful for calculation and units. Okay, I focus from the introduction session for that. Units, calculation. So the correct answer is C, turbulent.
If you don't mind, Doctor, can we just review again the average? Means if it is above 2,300, it should be like below 2,300 be laminar, above.
Yeah, the ranges?
The ranges of laminar
values,
and turbulent.
values, yes.
Okay.
That's only the number. Thank you.
Okay, I will tell you. And I have another answer, question here. How we know what? What is know what value? Jig Muhammad, based on the values? Okay. Same questions. Yeah, this we will see today. We will see this today during session today. 2,300, 4,000. Below this number is laminar. Above this number is turbulent. In between transient. Okay, that's it. Below this number is laminar. Above this number is turbulent. In between is transient. Okay.
Clear.
Now it's clear. Any question? Okay. Exam finished. I give you 1 minute. Not go. I just prepare the presentation. So you can write it your question engineering Muhammad, I think. I will check who engineering. I think engineering Muhammad. You have a question related for Kahrama. You can write it now. Let's go to another sharing. I don't know, but we can check. No problem. I will take it and I can check this one. Just a minute. I will go something. Let's start. Continuity equation. Actually, I start by this equation during the exam, but here just more details. But I focus for the what we said already in the exam. Here, the term is in the continuity. What's meaning first for continuity equation? Continuity equation is conservation of mass. Conservation of mass. So the terms is three terms. This already we see in the exam question, sum of m dot out and sum of m dot n. You tell me I see q, not m dot. I will tell you what is different between these two. So by the way, m dot out and m dot n. But the other term here is d by dt m control volume. What is this refer to? Actually, this refer to what is happening in the control volume. For example, if I give you the exact the same example for the exam, this is exam question, correct? We have one input here, and one output.
Mass.
This is the what? This is a control volume to study. I tell
Mass.
you, this is the area for study. Okay. You ask something? Okay. So this is the area required to study, correct? Okay. I ask you questions. You see here any mass, it is already accumulated inside here. What I know, you see any stored mass here inside? You have any stored mass here? It means the mass for the two input, it's not go out. Any mass going from the pipe should be going outside from this pipe. No, inside something is remaining. Anything going in, going out, especially for pipeline. So this one, we don't feed this term in these conditions. It actually zero, because this refers to what happened inside the control volume. This we can see normally for something like this. We have tank and we have orifice and we have flow here. And this flow is going increase, decrease, or something like this according to the amount of in, amount of out. So if I'm going to study the control volume for the tank here, I will check the control volume for the tank. I have in and I have out, and also I have a change inside the control volume. It's appear where in this term. So for normal equations, normal problems coming is pipeline problems. So this term we don't see in the solving equation for exam. So we will focus for the two terms here, this one and this one. So when this one is 0, the sum of m dot n is equal to the sum of m dot out. That's it. Still, this m dot, where is q? M dot, it is a mass flow rate. Mass flow rate. Mass flow rate, okay? And this related for unit of mass per unit time. M dot, M dot. So what is the M dot mass flow rate? It is equal to rho VA. So rho VA for out is equal rho VA for in, if we're going to multiply or apply for this case. We have one in, we have one out. In case of constant density, which is incompressible, and this is mentioned for this one, this condition, it's mentioned in the equation. If you back to the question in the exam, he mentioned to you, I have a fluid incompressible. So he tell you one information, incompressible, it means density constant, So for density constant, this row, it is the same this row, we can cancel together. If I cancel these two, it is now not m dot, it will be q. So this is the reason for using q direct, not m dot, because this is incompressible flow. When I can see the effect for density in the equation, if this flow, it is compressible, which is referred to gases, not liquids. Clear now? What's the name for this one? Volume flow rate. If you have any question, tell me, please. No question? Okay. This is one of the important equation ever in the exam. An ideal flow of any fluid must fulfill the following.
D.
Continuity equation.
Continuity equation.
D.
Another problem for continuity. Can you check, please? I give you 1 minute for reading and then going to solve.
Sorry, Doctor, please go back for the first question. Thank you.
Okay. Reading finished. Let's go to start solving. What's given? Given is given here already. Diameter, velocity. Diameter, velocity. Diameter and is required velocity. One input. Second input. This is the third, but this output. So 2 inputs and 1 output. Let's see what is required. The required is the velocity. So we can write the equation Qn equal sum Q out. What's QAV? So Q1 plus Q2 equal Q3. Let's substitute Q1 A1 V1 plus A2 V2 equal A3 V3. Okay, let's continue.
وطيله مجد وطيله.
A1 y over 4 d1 square, which is 10 square. V1 1 feet per second. By over 4 5 square 10 feet per second. By over 4 12 square V3. That's it. First thing we can do it, cancel by over 4 together, correct? Correct or not?
Yeah, correct.
Yes, all velocities here feet per second. So this will get by feet per second also. But here diameter is inch. For regular problems, this shall be changed from inch to feet to be matched with feet per second. Okay, this is important to change all inches to feet to be all matched feet with feet per second, feet with feet per second, not inch. Inch is not accepted. Okay, so it should be divide all by 12 to change it from inch to feet, divide by 12, divide by 12, divide by 12. But because this one all the same ratios almost, we have inch square, inch square, inch square, it will be feet square, feet square, feet square. We divided for the same number, 12, which is 12 square is 144, 144, 144. So we can cancel also together like by over 4. But please, if you are not sure, change inch to feet, because sometimes we have question like this: Q is equal AV, that's it, and we have a value of Q and we have a value for V, for example, or A, we have value for A, but this value is like inch, not like feet per second. Like this one, for example, is 2.8 cubic feet per second, and this one is by over 4. D is 5 inch, and this velocity. In this case, we can't substitute it here by inch. It shall be divided by 12 to be feet square. Match it with this one, feet. Match it with this one, feet per second. Okay? So inch in problems should be changed to feet, because almost all questions have feet. Okay? In many cases, some cases we keep it as inch, but in many cases, almost we change it to feet. This extra information, okay? Just to give you when I can use inch, feet, and so on. In this case, we can use it inch as it is, or we can change it as a feet as regular. For balance unit, should be changed to feet. But why I don't put it to lose time on something like this? Because inch here in two sides, in the left side and right side, we have inch here square and we have inch here square. So if you needed to change a feet square, we divide it on the same number here in this side, so it will be cancelled together. This it changed units. Okay, okay, this is clear or not?
Yep, clear.
Okay, so I will keep it as it is, but I know I get it V feet per second as this one is feet per second, this one is feet per second, and I know inches square is cancelled together. So let's continue the V3. This it will be 100, 25, 0, 144, V3. So V3 is equal 350 by 144 equal what? Anyone get answer?
2.4 B.
2.4. So the answer, exact answer is what? B. Okay. Bernoulli equation. Bernoulli equation is the second thing important in fluid mechanics. Bernoulli equation, it coming to study energy for the fluids. Study energy for the fluids. And it said this energy, it coming from three sources: flow energy, potential energy, kinetic energy. These are the three sources for the energy for the any fluid: flow energy, potential energy, and the kinetic energy. These are the three terms. Flow energy is described by B over rho. Potential energy is Gz. Kinetic energy is V square over 2, equal to constant, which is referred to total energy. But normally for the numerical problems, we don't use this one. It's not famous. Famous form, not famous form. The famous form used a lot in solving problems is head form. Also, it represents energy. Represent what? Energy, but in the shape of head form. Head form. So to change this one to be represented by head form, we divide all by G. So divided this one by G, B over rho G here. We put G here. We put here G. We put here G. G here cancel with G, so Z. G here is G rho, which is gamma. G here, will be the same, V square over 2G. V square over 2G equal to constant. B over gamma plus Z, it will have a name, bisometric head. And we have another name. What is this name? Static head. Static head. And the other one, V square over 2G, it is velocity head. Velocity head. And they have another name, dynamic head. And C is still total. But here it refers to total what? Total head. So we have static head plus dynamic head is equal to total head, or bisometric head plus velocity head is equal to total head. Also, we can represent this energy equation in pressure form. And in this case, we will see pressure form, so I need pressure alone. So multiply all terms by rho. So cancel this G. Cancel G. Cancel G. Cancel G. And now we write for all rho. So this rho here, rho here, rho here. What we'll see and what we'll get, rho, it will cancel with rho. So the remaining is P. And next one, rho G Z. Rho G is gamma, so it's gamma Z. This rho, it will be the same rho V square over 2 equals C. What is this first term? Is bisometric pressure. Bisometric pressure. And what is the next one? Dynamic pressure. Dynamic pressure. This also, we can say this one static pressure. Static pressure. And what is the total pressure? Total pressure. Okay. Now we see the form of energy in three forms. Equation of energy in three forms: energy form, head form, and pressure form. What's different? Energy form, unit of energy. Head form, unit of head, or meter, or length, feet, or whatever. Pressure form is unit of pressure. That's it. Okay. What's condition for this Bernoulli equation or energy equation for this? This energy equation, but we said for this one Bernoulli. Why? What's the difference between energy as a general and Bernoulli? Difference is Bernoulli for ideal. For ideal, there is no losses here. Energy is a general equation. We have losses, we have equipment inside like pumps. You'll see this next session. But now we study the regular one without any losses. No losses. This equation describes the energy along a streamline without any losses. Okay, without any losses. And this energy equation, also or Bernoulli equation, he said, it said what? It said the energy for any point, it is constant. This he mentioned here, constant equal constant total. It means that point have energy and another point have energy. But you said to me this flow is moving. So maybe the velocity change, pressure change, altitude or elevation change. Yes. But if one of these terms is a change, the other one is a change. So the summation of these two at the end, it should be the same. It means you have two terms, but the sum of these two terms all the time is equal. This one increase, it should be this one decrease. This one increase, it should be this one decrease. So up and down, but at the end, the total is constant along the streamline. This is Bernoulli equation. The Bernoulli equation is based on the assumptions. Which one?
There is no loss of energy.
All of the above.
All of the above, I think.
All of the above is applied in the assumption for Bernoulli equation. Euler's equation. Euler's equation, another approach from Lagrange. Lagrange is used to apply Bernoulli. This Euler equation is another approach to get apply or describe energy equation. Here it is not described by velocity, it's described by acceleration. So the total equation, it's not referred to the scalar values, it's referred to vector values. So it's more difficult to study numerically, but I just give you small information for Euler's. Used to study pressure variation, Newton's second law of motion applied to a fluid particles for inviscid and incompressible. So two condition is inviscid and incompressible.
Inviscid means?
Inviscid, it means the effect of viscosity is just small, very small effect of viscosity on the dynamic motion of the flow. This is inviscid. Static pressure, it is a pressure of flowing fluid at any point. Okay, this is normal flow. Pressure tape, it is a small hole in the pipe. This pressure tape. Read this one carefully, please, and then we're going to solve this exam question. Finish reading. Okay, let's start by describe the problem and tell you some notes. Here this flow is moving in the duct and we have two pipes. As you see, one pipe is just put it above direct to the flow. This one, it is one hole, but this pipe, it is actually, it's reach up to here from inside, but this like see from another side. The pipe is going from the middle of the duct, so it reach inside up to here, the pipe, but still pipe. But this one is just going, yes, but take L shape. And read this one here, this raised 2 inch.
Yes.
This also raised but 12 inch. Why difference? Why? These two pipe inside the same duct from the same point almost, but give different reading height. So why? The flow is moving, passing through the pipe here, but still the flow is moving. So this pipe, it measures only something is called static. Measure what? Static or piezometric pressure. Metric pressure. Okay? Because the flow is moving, we don't affect on the movement of the flow.
Yeah.
But here, the flow here, when you reach to the L-shaped pipe, is stagnant. Is what? Is stagnant. So what means of stagnant? Velocity now here is zero, not moving. So you change the type of the energy. Yes, because as you know, energy, we don't lose it. We change it from shape to another. So for here, this case, the flow stop and the velocity is zero. So it represented or it changed to another shape. So what is the other shape to describe this energy? It will affect on the height here to increase the height more than this one. So by default, this one should be increased 2 inch only, which is referred to the normal static, regular static path. But due to the also velocity stop, so the dynamic also changed it to height. So the remaining here is referred to dynamic. So this not only dynamic and not only static, this both. So this refer to what?
Total.
Total. Because as you know, total equal to static plus dynamic. Correct? First one, the movement of the flow not affect. So dynamic is in the energy, not affected. So what you feel here by this pipe, only static. But here, in this case, the velocity, it will be zero. So this one, it will be zero. So all energy going to refer to head. So it refers to static plus the other velocity going to also refer to head, another head. So it represents static plus dynamic. So static plus dynamic is equal to total. So here from this reading, we can see or read static and we can read total. This pitted tube, one of the famous method to measure the velocity. Okay, what is required? I tell you here in this problem, this is stagnant point and water raises here is 12 inch and this raised is 2 inch. The required is flow rate in the pipe. He requests Q. Flow rate in the pipe. To get Q, happy face, what's Q?
VR.
AV.
AV. They use the diameter here for the duct itself, this duct. 6 inch. So let's see Q equal AV. A I have, because I have diameter. So the remaining is velocity. How to get velocity? If you remember the equation for energy, he said total energy, H total, equal H static plus H dynamic. Can you write it by formula? The total, which is C, is equal to static, which is P plus gamma Z, B over gamma, sorry. B over gamma plus Z. This is what? Static. plus H dynamic, which is V square over 2G. P over gamma plus Z plus V square over 2G. That's what? Dynamic. This what? Static. Okay. Let's check first. What you read here? Static. This one. And also other one is total. So from these two you can get what? Dynamic. And this dynamic equal what? V square over 2G, which is included velocity. So if I know this value, I can get what? Velocity. You understand the way now for answer? So we can answer H dynamic equal H total minus H static, which is equal to 12 minus 2, which is 10 inch. Okay, this equal to what? H dynamic, which is equal 10 inch equal V square over 2G. What you need? V to can continue to get Q. So V root 2 multiply G. What is G?
9.81.
32.2.
32.2.
This G 32.2 feet per second square. Multiply what? H, which is 10. Accepted 10 inch? No. Should be divided by what?
By 12.
By 12 to what? To change it from inch to feet, correct? So this one is feet. This feet per second square. So feet square per second square divided per root like this, it's get it feet per second. So what is velocity here from this equation? We can check and get the answer. After you get V, you can get Q. So Q L, which is pi over 4. D equal what? 6, but 6 inches it is? 6 by 12. Why? Because the velocity is feet per second. So this one should be feet also. Multiply the velocity, which is get it here. Anyone get the answer or something like this? Anyone check? One solve? I get this one. You can check again after me. Yes, excellent. So the final answer. Continue without remove the previous. You don't get answer? .44 cubic feet per second. Okay, but please check what is the, because I don't have the choices actually here. Check the units for the answer. This one cubic feet per second. Maybe he needed by cubic feet per minute. GBM, liter per second. Okay, CFM. So after you get the answer, check what is the units required. Any question? No question? Here, read this question, please. Give me answer. You can, at the beginning, just check the choices without any reading on any see the figure. You can keep this one hidden, and the question you can keep it also hidden, and just read the choices. You can select the answer. Trust me.
Is it B, doctor? B.
B.
Because they're asking the distance, and of course I'll not make any calculation, but they're asking distance. Distance should be in unit, like meter, centimeter, whatever. So option A.
Just close mic, please. Close mic.
Myself.
Close your mic. Close mic.
Okay.
No, not close. Near. Give it near from you.
Okay. Sorry. What I am telling, the distance should be per meter, per unit, meter,
yes,
centimeter, whatever. So first option will go for square meter, which is we cannot select. And second, can we select, because D squared divide on X, which is meter. So meter, if we say square meter to divide on meter, it will be also 1 meter, M. So this is the closest answer, or this is the correct answer should be, because the C is also square meter and D also square meter.
Which is depend answer on your
unit only.
Units.
Yes.
This plus, it means the unit above, after it is the same unit before.
Yeah.
Is a concept, whatever you talk about for length or no, but you talk about for equivalent units. Equivalent units. This one is unit of length, but this one is unit of something cube. BD square. So the length is cubic. Here is length is also unit of length, but this is square divided by unit, it obtain unit, which is the same unit of length, which is accepted. This unit of length, but this is square.
Area.
Accepted.
Area.
This unit of length, this is square. So it's not accepted. Two term different units. So the answer is this one. This one I bring it new in the equation to be aware what is the other information, what is the question, what is the meaning of each term, and I will tell you some notes for this problem. First, this body, submerged body, any body inside the liquid, it have some exerts pressure or forces due to pressure on the face of this body. This pressure is distributed from above point to below point, but this pressure is not equal. So the force due to this pressure applied is not equal. Why? Because as you know the rule, when you're going down, the pressure is increased. So the pressure here also increase like this, increase the distribution. Okay? So according to this distribution increased like this, the force due to this, the force resultant for these forces, due to pressure, the force resultant, it's somewhere not in the middle. It's below the middle or above the middle. It's below the middle because the maximum in below. So it's somewhere here. This equivalent for these forces. This force due to pressure, the resultant for all these forces distribution. Acting on where? Acting in point is called center of pressure, center of pressure, which is required actually here. This is the required center of pressure. What's distance from center of pressure up to the surface? What is the other here, other x here? The center of gravity. I tell you, anybody have a center of gravity to affect the weight down. This for affect the weight down, and the points force up. But the points force is the 0.4 points. But here this g, this point for the body, it depends on the shape of the body. Correct? Okay. And this is what center of pressure. The required here, for example, distance of center of pressure from the surface. How to get this? It is equal to x bar, which is the distance from the center of gravity up to the surface, plus this area, this distance. This is a small distance. How to get this small distance? By this equation. So x bar, x center of pressure is equal x bar plus I bar divided by x bar area, this I bar. What is I? Second moment of inertia. What is x bar? This x bar is distance from the centroid or center of gravity to the surface, and the area is the area of the body. This I, it depends of the shape. For example, this rectangle, you have equation for the rectangle. If this square, you have equation for square. If this circle, you have equation for circle. Semicircle, you have semicircle. Quarter, quarter, and so on. Any shape, you can get it on regular shapes, like in the textbook or geometrical textbook or something like this. You can find the I for different shapes. So I is depend on the shape, area is depend on the shape. So the only x bar is measured from the problem itself. Okay. What I need here from this problem to be aware and focus for this thing, the distribution of pressure. Okay. And I think the solving of this problem, it is not difficult. Any question? Okay. Let's see some numbers important. Reynolds number, actually we discussed this one. Reynolds number is equal to Vd over nu, and regular equation rho Vd, this d actually refer to d over mu. D is meter, this d. Units is dimensionless. What is the definition? Important? Yes, ask a lot for this one. Inertia force by viscous force. Inertia force by viscous force. Again, inertia force by viscous force. Please be important. The range for Reynolds number to classify the flow, it is 2,300. Below is laminar. 4,000 above is turbulent. In between is transient. In between is transient. Mach number. Mach number, it's something related for measure the speed, anything related to the speed of sound. Speed of sound. To measure any body moved related to the speed of sound. So what is the Mach number equation? It is the speed of the flow divided by the speed of the sound in this flow. The speed of the flow divided by speed of sound inside the flow. Okay, because the speed of sound, it's not the same for all. The famous number we know, this speed of sound for air.
Mute ولا unmute؟
Okay.